Let me start the recording. There we go. And I will now start the screen share for you guys. Screen one. All right. So here is the finished, basically, game one that was made last week. Alex made that one. I'll just show it off a little bit. Basically, there's a bunch of ghosts on the screen. You can move around and shoot. Notice the wherever I point my mouse is where the gun is pointing. I can shoot by clicking. Ghosts are spawning in at, every so often. And yeah, so that's the basic game right there. You can see the ghosts accelerate towards me and stuff. It's all using basically physics. But that's finished game. You die when a ghost touches you, like it just did there. So basically the game's over. And there is a little thing at the bottom there that says game lost. So I have a few ideas on how we're going to expand on this game. So, any questions about this game before I get started? All the code is on GitHub, and there's also the video from last week is posted on YouTube, so you guys can take a look at that afterwards if you'd like. But for now, we're starting with just a clone of that game, and we're gonna build on it. So let's get started doing that. I'm gonna be doing everything kind of off the top of my head. I prepared the ideas and kind of how I'm gonna do them, but I haven't actually done any of the code. So I might make mistakes, and if I do, we're gonna work through them together. So I think that'll actually end up being kind of nice. All right. So first thing I want to do is when we play the game, we shoot out one bullet at a time, which is, it's okay, I guess. But I was thinking it would be cool if we had a more shotgun-like weapon where we could shoot out multiple bullets at once. So instead of shooting one, we'd shoot 2, 3, 4, 5. And the idea is to make a system that will allow us to, in the inspector, pick how many bullets we want to shoot, and then shoot that many bullets all at once. And you'll see that as kind of the theme for today. I want to make everything available kind of in the inspector here. I want as much stuff to be game designable as possible. So you'll see what I mean when we get into that. First thing I'm going to do is open up the player movement script because this is where the shooting is. Right here. So let's first think about defining the problem. We want to be able to shoot out N bullets, presumably at within some angle. So let's figure out how we're going to do that. Let's start with some variables up here. We'll say public int num-bullets. This will just represent how many bullets per click. So it's not so it's not like a magazine or anything. It's just how many pellets of a shotgun or whatever. And we'll start that out as 1. And then we'll also have public float. What should we call this? Cone angle, I guess. So this is going to represent what angle our bullets are going to come out as. So let's start that as 90, I guess. 90 degrees. So basically, our cone angle is going to represent, let's say we have 3 bullets and it's at 90 degrees. 1 bullet is going to come out 45 degrees to the player. 1 bullet is going to come out 0 degrees. And the last bullet is going to come out negative 45 degrees. So now that we have these 2 variables defined, which should be all we need unless I'm missing something, we're going to come down to here where we're doing all of our fun code. So right now what it's doing is we click the mouse and then we spawn a bullet, give it its position, give it its rotation and stuff. So what we're going to want to do basically is use this code, but we're going to want to use it multiple times. So I'm actually just going to condense it just a little bit like that. And we're going to wrap it in a for loop. So if anyone needs a quick refresher on a for loop, let me know. But otherwise, I'm just going to keep going. You can either just speak up or say it in VC text I'm watching. So I'm just going to put all this stuff in a for loop like that. And our for loop is going to look something like it's I equals 0, I is less than bullets, I plus plus. Standard for loop right there. And then the second thing, so this will actually work pretty well, except what it will do is it will just stack the bullets. So let's actually give that a shot. Let's see if we can actually even see. I don't know if we'll be able to see what's going on, but we'll try it anyway. Play. If I shoot, you can't really see it. Oh, well, first of all, num bullets is 1, so first of all, we have to change. I'll change this to something like 5. That would help a little bit. And then if I go like this, you can see that in my my inspector, or my hierarchy, I have a lot of bullets. I mean, there's only 5 on the screen right now, and I believe there's only like 5. Yeah, there's only 5. But there's quite a few over here. All the bullet clones, that's 1 bullet. The reason for that, if I could see, is because, we have 1 bullet here. We have another bullet there, another bullet there, another bullet. Yes, so basically all 5 of these are stacked onto each other. So we know it's working. The code is working. What it's doing is it's doing exactly what I said. It's shooting out this many bullets. The only issue now is that they're all given the same position and the same rotation. And since all the bullets move the same, they're basically moving as 1 clump of 5 bullets. So we're halfway there. The next step is going to be to shoot it like a cone. So let's get on that. Let's try to, there we go, turn focus to the player. All right. 1 minute. There we go. Okay, so next up is the cone. We're going to have to use a little bit of math for this. So we're in 2D, so it's pretty simple. The z-axis here, our rotation degrees, is equal to our player's rotation. So because we're in 2D, the z-axis is a blue one there. It's basically in and out of the screen. So when we rotate, it's rotating. See, it's the blue circle. It's rotating about the z-axis. You can see the z rotation changing there as I change this guy. So what's happening is we're keeping track of that that z angle at which we are rotated, and then we're giving our bullets that angle, which makes sense if we want them to shoot out straight. But if we want to give them a little bit of an angle, that's gonna have to change a little bit. So basically, this here is what's going to be changing. So let's start out with var forward. Actually, I'll make this more clear. I'm going to do vector 3. Or what is this? This is a float. Okay. Forwarder equals rotation. Oh, this is misspelled. I think that's why it's. Actually, let me change that real fast. There we go. Okay. Rotation degrees. So basically, this forwarder is going to represent what angle we're going to want to go at if we are moving the bullet directly forward, so straight in front of the player. Then what we're going to want to do is, depending on which bullet we're dealing with, we are going to shoot it at that angle. So I'm thinking now about how we want to do this, because if we have, there's an easy way, there's a slightly harder way. Let's just do it the easy way, because it's easy. So basically the idea is that if we're shooting out, let's say, 3 bullets over a 90-degree cone, we're going to shoot, or rather 4 bullets over a 90-degree cone. We're going to shoot 1 bullet at 0 degrees, 1 bullet at 30, 1 bullet at 60, 1 bullet at 90. That's going to give us a nice even spread over the full angle. Alternatives to this would be using randomness maybe or something like that, but we'll use that later, so we're not going to do that now. We're just going to make it a nice even spread over the angle. So essentially what we're going to do is divide the so basically what we're going to do is we're going to take the full angle, so the angle we want to spread out of, over, divide it by the number of bullets we want to shoot, and then place one bullet at 0, and then the next one at, that, however much we're supposed to do it by, and then the next and the next. So let's actually change this to start. This will make more sense as I do it, but let's change this to start direction. It's going to represent the direction at, and let's also move it out of the for loop. It's going to represent basically the direction of the first bullet. So if you think of a 90-degree cone in front of the player, the first one's going to shoot up 45 degrees always. And then all the other ones are going to shoot, some angle below that, some angle below that, some, and it's going to keep going until we reach the last bullet, which should be at negative 45 degrees. So our math is basically going to figure out, okay, what's that angle that each bullet needs to be shot at lower in order to get a nice even spread. So we're going to start with this, and this is going to be what I call cone angle over 2, or rather plus, I believe. I'll be able to check that's plus or minus. It should be plus. All those Z's into it. Let's find out. Yes, it is plus. Okay. So basically what we're doing here is we're saying, okay, the starting direction, so again, 90 degrees cones, we want to shoot at 45 degrees up. So what this will do is we're saying, hey, wherever we started, right, because we want to shoot 90-degree cone in front of us, plus, and then this here is just going to make sure that we're shooting 45 degrees up. If this were 90 and this were, say, 0. All right. Then next thing we're going to want to do is get float, and we'll call this angle change, I guess, pretty descriptive. And this one is going to be our cone angle over, and then I'm going to just say num bullets minus 1. The reason for this is because if we have 2 bullets, we want them to be well, let's think about having 2 bullets. We want them to be spaced cone angle apart. What that means is that let's say we have a 90-degree spread and we have 2 bullets. We want one to be placed at 45 and the other one to be placed at negative 45. If we just said cone angle over num bullets, angle change is going to be 45, right? Because that would be 90 over 2, which is 45, meaning the first one would be placed at 0, and the second one would be placed, the first one would be placed at 45 degrees. The second one would be placed at 0. So basically we get one shooting up and to the right, and one shooting just to the right. Instead, if we want an even spread over the full 90 degrees, we want one shooting up to the right 45 degrees, one shooting down to the right negative 45 degrees. So that's why this little -1 here is here. It's just math. You can play around without it if you want to see why it's there. All right. And the last thing to do is to change this to what it actually needs to be. So it's going to be start direction. And then in this case, I'm going to be subtracting the change because we're starting up and we want to move our way down. Rotate clockwise, which I guess is negative. It's negative in this case. And then we're going to want to say, okay, everyone's starting the start direction. And then we're going to use I here, our iterator. I times angle change. So more or less what this is doing is saying, okay, we're starting at, say 45 degrees. And then if it's the first bullet, that's going to be 0. So it's just the starting direction. If it's 1, it's going to be starting direction minus 1 times the angle change. If it's 2, it's going to be starting direction minus 2 times the angle change. And basically when it's, the number of bullets, it'll be whatever cone angle is. I'm sure you could do math and solve that, but yeah, that should work. Let's give it a shot so we can actually see what the hell I'm talking about. So we have 5 bullets, 90 degrees. So let's make sure this works. Might not, who knows. But it does work. There we go. So notice I can shoot a nice big thing in front of me. When I rotate, the bullets rotate with me. You can see they're shooting out like that. Perfect. Yeah, pretty much exactly as I expected. So if you have any questions about this or any of the math, let me know. If not, let's just play around with it a little bit more. There's a lot we can do with this. come back to the player. We can change a lot of this. So let's say we want like a much tighter spread. Let's change that to 30 degrees. Hit play. We're going to see the cone is now just a lot tighter. It's not as wide. Another interesting thing that maybe, I don't know if this is really how you'd want to implement it, but it would work, is our bullets despawn when they hit a ghost. You can see they go away when they hit a ghost. They don't penetrate. So in theory, if you changed the cone angle to 0, which, looking at our code, makes the start direction just the regular one, and then makes angle change also 0, because 0 over whatever. That means that every bullet will come out at the exact same angle, basically meaning we getting stacked bullets like we had before, but also meaning that that bullet, oh, I guess it doesn't. Just kidding, it does not penetrate because of the way that it's made, but that would maybe be a way to make that work. What I was trying to do there was the first bullet hits and then it despawns and kills the ghost, but then there's still 4 bullets under it, so then those 4 keep going forward. But I think the way the code works now, it's just despawning all 5 at once. Yeah, but that's a thing that you could get to work theoretically. You could also do some crazy stuff like 180 cone angle, which will give us a really big thing, 180 degrees around us. Could even change that to 360. Oh. If we change it to 360, we could have a ring of cog happy around us. Like that. So you can see we're getting in 4 directions. Yeah. The reason it's coming out in 4, not 5, is just because of the way the math works. It tries to place, it's actually 2 here. Don't really need to worry about that too much, probably. All right. So let's change it back to, I like 30. And let's do like 3 bullets. So that way it's just a little, we still get a little bit more power than we originally had, because now we have 3 bullets, but it's not too powerful. Let's actually make it even a little tight. Let's go 15 degrees. All right. So that was like step 1 of enhancing our game. Really, all it was adding this for loop right here. And just like that, we went from shooting 1 bullet, right, which is not very configurable. You shoot 1 bullet straight. That's fantastic. Great. Good for you. Now we can shoot some number of bullets in some cone angle. And we have a lot more control over our game. If we ever want to go back to shooting 1 bullet, just change the cone angle to 0 and change number of bullets to 1. And then we'll have exactly what we started with. So as a game designer, this gives you just a lot more flexibility and a lot more control over, the actual gameplay and, that stuff. Further, to add on to that, let's say you wanted power-ups. Super easy to implement power-ups. You pick it up, change num bullets at 3, change the cone angle, and then after a certain duration, reset them back to their original values. Super easy. You could even maybe stack them. Maybe every one you pick up boosts your number of bullets by 2 for 5 seconds. So it just literally adds on here, plus 2. And then, that way you can even stack multiple power-ups. As they run out, the number of bullets you shoot maybe starts going down again. Just doing this, even if you don't need it, even if you're using cone angle 0, num bullets 1, which is going to give you, again, 1 bullet just directly in front of you, you have a lot more flexibility, and there's a lot more places to go from this code than, than the other code. If you want to do power-ups, whatever it is. All right. So moving on from that, if there are no questions, assuming there are not, I'm going to be trying to make a alternate bullet. So the bullet we have now, let's take a look at it, is this one. It moves along some scripts, or it moves as per some scripts and all that fun stuff. So I'm actually going to copy it. Where's duplicate? It's not there. All right, Control D duplicates. And I'm going to call this one, let's rename it. I'm going to call it Wavy Bullet. You'll see why shortly. I don't actually think I have a texture for this, which is a little unfortunate. Oh, you know what I can do? I can just change the color. Green. Is that not? Yeah, there we go. Green is the Wavy Bullet. All right. So this is going to be our Wavy Bullet. It's called Wavy Bullet because we are going to modify this bullet script, or we're going to write our own, rather. Um, that's not what I meant to do. Yeah, so let's add component. Going to call it Wavy Bullet. Create an add. And then we can wait for it to load, and then I'm going to remove this bullet script. So basically it's a copy of the other bullet, except it's going to be using this new script called Wavy Bullet. And you'll see why in just a moment. So coming over here, let's move this into the right folder. Nice. And let's take a look at Wavy Bullet. I'm going to open up Bullet on the right just for you guys to see. So I'm going to zoom in a little bit so you guys can see better. So basically what we're going to be doing is copy and pasting all this code in, because we can just yeah, there we go. Yeah, so we're working from this bullet, but we're gonna do our own thing. So actually, yeah, we'll do this for now. I'm gonna try something at the end. I'm gonna see if we can just inherit bullet and if we'll get all the methods, but we're gonna try this for now. All right, so the idea of a Wavy Bullet, what I want it to do is, instead of moving in a straight line, it's going to like move along a line, but also as it goes, it's going to move up and down in like a wave pattern. So think of like the way a ghost will move to the right, but then, or not one of our ghosts, but like you think of like a cartoon ghost, it moves to the right, but it also is bobbing up and down the whole time. So basically like a sine wave is essentially where I'm going with this. So the way our code works now is we translate 1 unit on the x every tick, every update, every frame. So what we want to do instead is move to the right and move either up or down depending on where we are. So I think this will work. We'll see. It should. Yeah. So let's start here. Basically all we're going to need to do is change this y value here, which is 0, basically saying, hey, don't move up or down. So we're going to say, hey, you need to move some amount up or down. So what is that amount? Let's say float. We'll call this up or down number, I guess. I don't know. And what are we going to want it equal to? So every frame we're going to be moving this amount. So if I want it to move like in a sine wave, I'm going to use cosine here, derivative, blah, 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 mathf cosine. And then for the cosine, we can just use time.delta time. This will kind of be like x on cosine. I'm assuming you all know what cosine looks like. It's like sine, but shifted over a bit. And then if time.delta times our x, what we're going to get is a nice function that will go up and down, or down and then up technically. We can also make a variable up here called public float bobbing speed. We'll set that equal to like 5. And then we can also multiply that here. And then we can add one more variable. I'll go over all this at the end. Don't worry if you're getting a little lost. Public float bobbing amplitude. Set that to, say, 4. And we can change that later. And then we're going to multiply it here. So, and then finally, to actually implement this, we change this y0 to up or down number. I guess we should call it the bob factor. Let's call it the bob factor, as in bobbing up and down. All right. So what does this do, right? So again, cosine is just a function that will periodically go up and down, which is why we're using it, because we want to go up and down. So there are many ways to do this. I like cosine because cosine is super easy to write. But if you didn't want to use any math, what you could do instead is, if you guys took came here to the first Unity tutorial I did, in order to check if we'd moved far enough, we just checked our position. We said, hey, is my x coordinate greater than 3 plus where I started? That would be another way to do it. But I like this method because it's going to give us really smooth movement, and it's super easy. So bobbing speed times x, basically as bobbing speed increases, x increases faster, cosine's going to have a shorter period. So we're going to start going up and down faster. And bobbing amplitude, so basically increasing, because cosine goes from -1 to 1. This will just make it increase or decrease. So basically we'll move up more or down more. So we have a lot of control over how much our bullet's going to be moving. We store that here. We use that here. Let's see if this works. To test it, ooh, actually, Actually, let me see how, we have to see how player movement works. Is it on a bullet or it wants a game object? Awesome. So coming into Unity to test this, what we can do is take our player. Notice it uses the bullet prefab, right? Let's give it the wavy bullet prefab, just like that. And because this is Unity and we coded it well, it's plug and play. Oh, looks like it doesn't want to work. Why is that? That's interesting. Let's try that one more time. Oh, I think I might not have set the variables. Oh, I know why. Do I? That's also on layer bullet. I mean, I copied the bullet script, so can't be that wrong, right? Oh, speed. Let's change that to 10, maybe? And then lifetime. Okay, that's the problem. So the problem is it was A, not moving, and B, dying instantly. If you remember destroy, which will destroy a game object, it was basically happening instantaneously. So it was being instantiated and then immediately destroyed. Oh, wow. Yeah, so that's pretty intense. Maybe we should slow that down a little bit. Set the speed to 1. Bobbing speed to 0.2. Looks like it's going really fast. Let's just set it to 0 for now to make sure that we're actually moving, first of all. Okay, so our bullet's working. Let's change this to 0.2. It's just about playing with numbers at this point. Definitely way too high. And then also I'm going to make sure we can only shoot one at a time, because otherwise it gets really confusing. One bullet, please. And then we'll head back here, and we're going to start messing around with these numbers. So bobbing amplitude, let's set that to 1. That should give us a good feel for how far up and down we want it to go. There we go. Oh. Actually, can I? We're going to disable the enemies real quick. So let's hit play. I don't think the spawner should work now. Oh, just kidding. The spawner definitely works. Let's disable the spawner too. All right, there we go. So now let's hit play. And let's watch. Oh, God, there's still that guy there. Okay. So we shoot. Our bullet goes up. Keeps going up. Why is it still going up? All right, clearly I messed something up. Let me try something. Bobbing speed should be higher. Amplitude should be lower? Question mark. Oh. I think I made a math mistake. Huh? What does this want? Compare approximately square magnitude result. What? To be honest, I don't even know what that means. I don't think that's too big of an issue. Unless it is. Who knows? Alright. So this guy isn't working. Let's figure out why that is. Take a look at our code here. So cosine, blah, blah, blah. I think we should be able to just keep playing with it and play with the numbers and see what's up. So we're going to use the inspector here to help us out quite a bit. Let's go project, Wavy Bullet. Here we go. So bobbing speed is 5, bobbing amplitude. So let's change that to much higher, so like 100. Or let's do 10. Okay, it's just going up. Oh, it's because it's in radians. that actually the reason? Let's find out. No, it just doesn't want to do it at all. Very cool. Might have to abandon this idea. Maybe I'll come back to it at the end if set a few more zeros in there. All right, I think we're going to come back to this one. I don't know what that's complaining about. If I give it the regular bullet, is it going to complain still? Let's find out. It is. Okay, so that's clearly not the problem. Choose top shooter, translate, pop vector, times time to delta. Oh, it's times time to delta time. Is that the issue? Or is it coming out at an angle? Interesting. Math cosine time to. Oh. I made a mistake. So the issue was I was using delta time, which is going to be more or less the same every frame. And cosine is going to require our x to advance. So that's the issue there. This should really be time.time. So basically what was happening is time to delta time is pretty stable for our game at least. So since it's stable and bobbing speed is constant, this is a constant. Math.cosine is a constant. So basically it was moving upwards y at some constant. So let's try this again. This time we are going to use time.time. So like our x-axis time. Hit play. And now we should see, oh, that's our regular bullet. Let's switch back to the wavy bullet. And then wavy bullet, bobbing speed, let's make that, let's try 1 and see what that looks like. So now we can actually play around with the values. Theory, it should work. I'm pretty confident this time. Ooh, there it goes. Okay, I think that's correct. Let's change the bobbing speed up just a bit. There we go. So it's actually working. As it goes across, you can see it kind of moving up and down. It's like waving just a little bit. We can make it wave more if we increase the amplitude. Oh, wow. Really did not like that. Nice. So maybe not this much. This is kind of funny. I kind of like this. Yeah, I think the issue is just that since we're moving it by that amount, instead of yeah, I don't know. It's because it's probably like it's like a time thing. Because we're moving it by like a certain amount each frame and not like moving it not setting its like y position or x position or whatever specifically to some value. It's being a little jittery. But honestly, I'm kind of okay with that. I think that looks kind of spooky coming at you. Let's change the speed down a little bit. Because the goal of this bullet is not actually to be shot by the player. It is for an enemy to shoot at us. So, it also just straight up does not respect which way we're facing. So let's fix that too. But yeah. So the goal is basically for an enemy to shoot this at us. So that's going to be our goal. So we're going to give our player back his bullet. Hit play, make sure it's working. Because for some reason, okay, I think I just broke this. Huh. It's amazing how you can just break everything in Unity. All right. What did I do? So now apparently I can only shoot straight. That's pretty impressive. All right, let's fix that issue now. Player movement. Start direction plus 0/2. This is order of operations, right? Yeah. Start direction minus, okay, this is order of operations. Angle change 0 over num bullets is, oh. So the issue is that num bullets might be 0 or might be 1, and then 1 minus 1 is 0. So these are all the fun little math issues we sometimes come across. So let's fix that real quick. just think about it. When we have 1, what do we want the answer to be? If we have 1 bullet, then we can just say it's 0. So we can use an if statement. If num_bullets equals 1. So angle change, if we have 1 bullet, then we're going to say angle change equals 0. We don't really care. Otherwise, then and we can even get fancy and say less than or equal to 1. So basically the issue was that I was saying, num_bullets -1, but if we're shooting 1 bullet, 1 minus 1 is 0, cone angle divided by 0 is, undefined. So that was the issue there. And then it was basically this was throwing an error, so it couldn't get anything done. Now what we're doing is we're saying, hey, we have an angle change. And then if we're somehow shooting less than 1 bullet, which we shouldn't be able to, but whatever. Basically, if this would be 0, then just say it's 0, whatever. We don't really care. It's 1 bullet. Otherwise, we can actually do the math because this will definitely be greater than 0 in the denominator. All right, so wait for this to load. We'll double check it. All the enemies are still good. Good, now we can shoot any direction. If I attach the wavy bullet, the weird wavy bullet, we can now shoot it in any direction. Looks kind of spooky. You could slow it down a little bit more, maybe. We'll see. All right, and that is now its own bullet. So thinking about this in a game design sense, right? Like what can we do with this? So this bullet might not be, the greatest thing in the world, but if you think about it like, what other cool bullets could we create? If you wanted to create a bullet that, say, when it hit a ghost, when it hit the enemy, it exploded into 8 more bullets, right? Kind of like a chain reaction. You could do that. You would make a new prefab, give it your own scripts, maybe call it like exploding bullet. And you saw how similar these two things were. For example, for an exploding bullet, it would probably be the same as this, except instead of destroying itself, it would destroy itself, but before that, it would, spawn 8 more in a circle, right? And then that would be your exploding bullet. And, spawning, we know how to do that. That's instantiate. The same way that we shoot with the player to create a bullet, we would do that here. So it would do that, then destroy itself. So basically destroy like the 1 bullet and make 8 more around it. Maybe they go out in a circle, whatever. But yeah, you can get really creative, and you can have all these different bullet scripts. And then when it comes to actually putting them in your game, you can define a way they look. Define, here I just did colors, but you give them their own separate sprites. You could do all that fancy stuff. And then to swap them out, drag it in. It's easiest thing in the world. You can also do it through code. You'd have to like get the asset and stuff. It is possible. It's not that difficult, but I won't go over it here. So that makes, swapping things out, moving things around super, super easy. Really, really good for game design. You can test things super easily. That's why you like this bullet prefab thing here. That's why we use prefabs. They're nice. All right. Any questions about that? All right. We are going on to trying to make a new enemy now. This new enemy is not going to move, but is instead going to spawn in and then just constantly look at us, and every so often it's going to shoot. So it's going to shoot those wavy bullets, I've decided. We're going to slow them down a little bit. Like that. Awesome. Actually, the reason... Wait, hold up. I need to try this. I think that's just really fast is the issue. I think it was like jittering up and down. Was that actually the issue? Oh, wow. That actually was the issue. Okay, this is actually what I wanted. Much closer to it. There we go. We could even change this to like 20, maybe. There we go. Maybe 10. Oh, there we go. That's beautiful. I like that. Very cool. All right. That's much better. Yeah, I don't know why I thought 300. I was way too fast. All right, cool. So now that looks a lot better. Very cool. And you can see this little variation. That's just math that could be fixed through figuring out how to make it the same, but we're not going to worry about that. All right, so getting distracted, new enemy. All right, so the way we made this enemy, you can see it is a prefab if we hop here. It's got its own sprite. It's got the collider to kill it, has rigid body giving it physics, and it's got the enemy script. So here what we're going to want to do basically is modify the enemy script, but most of the stuff besides the sprite can be the same. So I'm actually going to duplicate it again just because it's easy. Control D, getting us enemy 1, and let's rename it to shooter enemy, I guess. So we have our regular enemy, and then we're going to have this like variant. So first thing we're going to do is change the script. No one submitted any assets for the workshop, so I had to make my own. So I'm very sorry about this. So we have our gun enemy here. You can see it's beautiful down here. Just realized the gray blends in completely with Unity. There is something there, I promise. It's not just a red dot. And then here we're going to want to give it a new script. So let's call it shooter enemy. Create an add. And then we can also just remove this one off here. Awesome. So let's look at the code. Well, everything else is good. Yeah, we have the enemy layer. Okay, everything else is good. Go over here. Move this into the scripts folder. And let's get started. So we have shooter enemy. And we have regular enemy. I'll move this one over, split right. And we're going to do the same thing. Just copy all the code because some of it's going to be shared. So what do we need to change? First of all, here we make the enemy, this base code here, makes the enemy move towards the player. We add a force onto the rigid body. That's what gives them they move towards you, they accelerate, and they go past, and they slow down. Really cool effect, but we're not going to use that for this enemy. This enemy is going to stand in place. So instead of applying force, we're going to make him look at the player. So luckily for us, Unity is very nice, and it provides transform.lookAt. So transform is, of course, referring to the transform of the shooter enemy, so the game object this is on. And then we just give it something to look at. Now we're already given the player's transform. That's a field we have, so we can just say, hey, look at the player. Very easy. And then yeah, no, we'll keep doing this. All right. If the player hits it, it dies. That makes sense. There's one more thing we need to do for that, and this guy, and it's actually make him shoot. So the way we're going to make him shoot, we can actually remove his speed and his rigid body. We don't need these anymore. So basically right now, what's going to happen is if I were loading the game, if this guy were there, he would just continuously rotate to look at me. Let's see what that looks like. Okay, let it load. Oh, he's so small. Let's make it a little. Let's make it a little bigger. Open the prefab. Okay, open prefab. I think oops. Should be. There we go. Okay, he's so small. He needs to be a lot bigger. Let's do 10. That's way too big. Let's do like 4. All right. What does this look like? Ah, there we go. He's like about the same size, and his hitbox is a little scuffed, I think. Shooter enemy. I'm in game view. Yes, hitbox is a little scuffed. Let's see if we can actually change that by just doing this and then just giving him a little bit of a nicer hitbox there. Good. We're gonna call that good enough, I think. Don't really care too much. All right. So, and then let's also just make it just a little bigger, just because. Oh, open this. We have to edit the prefab. Okay, and then we're gonna make it just a little bigger. Let's go like 6, 6, 6. That's a bad number. Let's go 7. There we go. Very nice. Is there actually a way to make this smaller? Oh, we can. Okay, we're going to just fit this a little bit better. So that it doesn't feel unfair if we die to it. We want it to feel fair, so we're going to make the hitbox as small as we can. All right, there we go. That'll be good. Save that. Exit out. There we go. Now we have our shooter enemy. Let's delete that, bring him back in. There we go. All right. Oh, we're in perspective. That's why it seems so small. There we go. So he's a little bit bigger than the player. And, ooh, look at might use the Z axis. So let's see how this works. Might not. It indeed does not. Let's double check this. Is this doing anything? Doesn't want to. All right, cool. It's because it does not give in the player transform. So because player transform was a field, we need the enemy to know, what it's looking at. So you can say, hey, here's the player. Now I still don't think this is gonna work. Yeah, no. So it actually looks kind of funny. Basically what's happening is its look at uses the forward direction, so the Z axis, which clearly is not working because we're in 2D. If you hop into scene view, you can see what's happening more accurately. The blue here is, that way. Is there a way we could fix this easily? Actually, there might be. Let's try this. I don't know if this will actually work, but no, it won't. Okay. So easy way to fix this. Instead of using look at, which works great in 3D, but not so much in 2D, we can do some like vector stuff. So first thing we want to do is find the vector between me and the player, or the player and me, either one. So we're going to say transform, or no, player dot position. So let's say, okay, here we go. Vector 3 or 2, I guess, 3, whatever. Difference equals player dot position minus transform dot position. So what this is doing is just getting a vector that points from, do some math real quick. I'm pretty sure it points from the player to me. I don't know. It points in one of the directions. If it's wrong, I'll just make it negative. And then what we're going to want to do is say, we'll have basically an arrow that points from here to here. And then we're going to say, hey, just look along that arrow. Make sure that you're looking along that arrow. So real quick, I'm just going to flip it. Alex showed this off last week, so that its right is the same right. Same thing as this gun. This gun was also flipped. Although, for some reason, he has up. I don't know. Whatever works. And then what we can do is just say transform.right equals difference. This should work. Don't think we have to normalize that. All right, if this works, I'll explain it. If not, I will try to find something else that works. Almost there, almost there. So technically, I will explain. Technically, it is working. Technically. If we go into scene view, you can see that it is indeed pointing at the our guy, except it's also rotating on the other axes is the issue. There is a way to fix this. Let's see if I can remember how to do it, because I've definitely done it before. If you just set, because you want it to rotate along the z-axis, right? So you say, does that work? Or it doesn't appear to work. Oh, wait, pause. 0, 0. Is that going to work? No, it's not. All right, so there is something we're going to have to do a little bit more math, I think. So again, Unity, even though you're in 2D, you're also kind of in 3D, so you have to deal with 3D rotation. So what we can do is find the angle in between the way we're currently facing. Or wait a minute. Oh, I know what we can do. Maybe. We'll see. So this vector, oh, it also might not work. We're going to try it. We're going to give it a shot. So right now, they're on different z-axes, you can see. So in 2D, this doesn't matter because you're looking at it like this and it looks fine. In 3D, there's a little bit of a difference. So let's figure out how we can solve this issue. And the way we're going to do it is basically say we have this vector 3, which is, again, there's a difference. So there's an x, a y, and a z component to this one. So call this only xy, can't have spaces, is going to equal new vector 3. And then basically it's going to be difference.x, difference.y, and then 0. So basically what we're doing is we're ignoring any like actual z distance, which again we don't care about because we're in 2D. So we only really care about the x and y, which is why we're doing this. Now let's try it. It still's not going to work, I'm pretty sure. But we'll give it a shot anyways. Yeah, no. So again, technically at this point it is working. Like it is looking. But you'll notice it does some like weird little flip things. And again, the reason is Unity is a 3D engine. Or rather, it really it is a 3D engine. It's called Unity 3D. So what's happening is it is pointing its right at my player, but it's also pointing. It doesn't really care about the forward and the up. It can point them in any direction so long as this right is pointed at the player. Now I think there actually, I'm remembering now, there might be a way to do this. I'm going to forget about it for now, and then come back to it because I want to make sure we have time to finish. But I do know there is a way to fix this. I just have to remember how to. So for now, it's going to look all wonky, and it'll be okay. Everything is fine. So if we move to our, the spawner code, we have a stopwatch here. This stopwatch is basically a timer keeping track of how often when enemies can respawn and all that stuff. So basically, we're going to be doing the same thing, except with shooting. So instead of spawning enemies, we're going to be shooting, but we're also going to use, same thing as in the stopwatch here. So if we come over to a shooter enemy, close this at this point, and give it a stopwatch, import that, please, thank you. And we're going to call this shoot stopwatch. All right, so stopwatch basically can measure time. So every so often we can do something. And we can look at the spawner code again for a reference on how to do that. Let's just copy and paste it because we can. Shooter enemy, boom. So basically, if we call this shoot stopwatch, dot elapsed time. So this is how much time we want to happen basically in between shots. So let's define that. Public float shoot time. What is spawn time set to? Probably nothing. Okay, we'll just leave it like this. We'll start it at, I don't know, it's in milliseconds. So 2,000 every 2 seconds. And then we'll choose shoot time. Then we're going to want to restart the stopwatch, and we're going to want to shoot. So we have to make our shoot function. Oops. We have to make our shoot function, but we'll do that next. So basically what this is doing, you can watch Alex's video from last week, but basically starting a stopwatch, we should also probably start the stopwatch would be a good idea. Shoot stopwatch.start. So this is basically starting the timer. And then every frame we're checking, hey, is the timer larger than how long in between shots? So for example, we start at 0, right? And it's 0. So it doesn't shoot for the first frame or the next however many. And then at some point, the stopwatch is at 2,000 milliseconds, which is 2 seconds. Or 2001 milliseconds, whatever. Bigger than 2. It's been longer than 2 seconds. It says, hey, it's time to shoot. So it restarts the stopwatch, setting it back to 0, and then it shoots. And then we'll just keep doing that over and over and over again. So we're finally going to need our shoot function, the last thing we need here. Private void shoot. And this is going to be actually shooting our bullet. We're going to do the exact same thing we did for the player, where, although we're not going to deal with like cones of bullets and stuff, we're just going to make it nice and simple. So first we're going to need to make sure we give it a bullet to actually shoot. So that's why I have this field up here, game object bullet prefab. So basically, what is it going to be shooting out? And in this case, we're going to give it our wavy bullet. But we could also give it the player's bullet if we wanted to. We could change it up over time, all that fun stuff. So shoot. And then we are going to basically, again, just copy from the player movement. It's good code, so reuse it. Grab it and put it. There we go. And then we can actually just remove this and set this to transform.rotation or .euler.z. There we go. All right. So I think this will work. Check this one, but actually, let me just double check that. Yes, okay. Float rotate. Oh, okay, I see how this works now. All right. So let's give this a shot. Let's see if it's working for us. Shooter enemy, 2,000 in between shots. Let's give him the bullet, the wavy bullet, and now let's see what happens. So come over here. So the issue is that the wavy bullet is acting the exact same way as the player bullet. So it's spawning in on top of the enemy, and then it's like, oh shoot, I hit the enemy. Time to die. So there's actually a nice easy solution for this, and it's actually going to be a kind of a cool one. So the bullet layer doesn't interact with the bullet layer. Alex said this last time. Basically, the idea is that the bullets don't collide with each other, so they don't destroy each other. Let me just double check something real fast. See how the best way to do this. On trigger, enter. Okay, yeah. So what we can do. So here we're actually not being very picky. Actually, we don't have to do anything with layers. Here we're not being very picky on when we destroy the bullet. We just say, hey, whenever we touch something, destroy it. And the reason it doesn't happen when we hit the player is because we've set the player and the bullet layers to not interact. So if a bullet hits the player, that's also something we're going to need to change. Yeah. So just for the wavy bullet, actually, let's just make it a new layer. Oh, no. Okay, I know what we're going to do. So wavy bullet. Again, this is all off the top of my head, so I know it's a little scatterbrained, but hopefully you can watch it back and understand if you miss anything. So for a layer, we're actually going to put this on the enemy layer. And the reason for that is because it will interact with bullets and like player bullets on the bullet layer and the player on the player layer. So layer is player. This one's on bullet. We're going to put this one on the enemy layer. So basically, I'm kind of treating it like it's its own little enemy that's following the player or shooting at the player. And then what we can do is here, we don't want to A, destroy other enemies, or B, destroy the gun shooting it, or C, destroy any other wavy bullets, right? So the question is, how do we do that? Well, there's actually a pretty easy answer, and that's, hey, if we hit an enemy, don't do anything. So one of the ways we could do this is the same way we did last time, where we go into File or Edit, Project Settings, Physics 2D, and then you just come here, and you would say like enemy can't interact with enemy. We could do that. Then none of the enemies could actually physically interact, and nothing would happen. But we actually do want this, because if you watch the game with all the ghosts, they do physically interact. They like touch each other, and then they like clump together, and they have collision basically, which is cool. So we want to keep that. So we don't actually want to remove that collision there, so we want to leave it. What we can do instead is just any time our wavy bullet touches something, we'll check if it's an enemy. So, and if it is an enemy, then we won't do anything, right? If it's an enemy, we won't destroy anything. We'll just continue on with our day. However, if it's something else, then we'll destroy it. So let's do that. And the way we do that is if other dot, And then what we can do is just get the game object. So collider 2D, it's going to basically give us the collider component of the thing we touched. Well, if that game object dot compare tag and basically say enemy, and then if this is true, we will break. I don't know why it's switching to yield break. Please don't. What's the issue? Oh, oops, return. All right, and then it's lowercase e enemy. All right, let's see what the actual thing is called. Oh, it is enemy. Did I misspell it? Why are you telling me this? Tag is not defined. I think it is. We're going to see what happens. Basically, what I'm trying to do is when the bullet hits something, whatever that might be, it's going to check, hey, is it an enemy? If it is an enemy, it's just going to return. It's not going to do any of this code here. But if it isn't an enemy, so it's a player or maybe another bullet, it's going to destroy it. Oh, that actually might be an issue. Okay, we'll see. We'll see if this becomes an issue. Might try to destroy an object twice. If it becomes an issue, we'll fix it. So let's see if it works. No, it didn't work. Why is that? Tag enemy is not defined. Oh, it's a layer, not a tag. There's probably a way to get layer, right? Let's try it. Oh, there we go. Layer equals layer dots. There's definitely a way to get the layers. So the thing about layers in Unity is here we go. Layer mask dot get. There we go. So the thing about layers in Unity is does this really need to be? There we go. The thing about layers in Unity, it's for like the third time, is we see them as strings, right? We see enemy, we see bullet, we see player. Unity doesn't see that. It sees just integers. And the reason is so it can do like bitwise math and stuff like that for masking. But essentially these are all integers. And you can just see enemy is 7, right? So what we're doing is basically saying, hey, if the object that we collide with is on the layer, is on the enemy layer. In this case, this is just getting the number 7. Now we know it's 7, right? We could just type 7 here. But like, what if it changes at some point? That wouldn't be very fun. So we're just going to basically say, we know a thing's always going to be called enemy, even if the order shifts around and it's no longer number 7. So we're just going to do that. All right, let's give this one more shot. Hit play and see what happens. Hopefully the bullet actually shoots this time. Of course not. All right, let's see what's up. Enemy is our shooter enemy on the enemy layer. It is interesting. Params layer names. If game object layer. Yeah, okay. All right, let's think about this. Think harder. There's definitely a solution somewhere. All right. Huh. Quite interesting. Did I update? Did I save? I did definitely save. Oh, there's an error. That's why. Where's the error? There's not an error? Oh. It said there was an error. Maybe, is that the issue then? It had a little red underline. That might have been the issue. Let's try it out. I don't know what the error would have been, but please. Okay, or not. So it's just showing the enemy, blah, blah, blah. We already tried to check if the game object layer is equal to this. All right, we're going to do it the easy way. If, we're just going to check the tag. Other.gameObject.compare tag. So tags are basically not layers, because layers are like physics things, but tags are a way to quickly identify objects. So for example, I can check if it has the enemy tag. So here, notice it says untagged. I think I did use this in my original Unity tutorial. I'm going to add a new tag, enemy, and we're going to give that here. So basically, And then for this guy, we're also going to give him the enemy tag. Okay. All right. All right, Pog. Let's give this a shot. If this doesn't work, then... okay, there we go. Okay, so that kind of worked. They're shooting out at a weird angle. I think I know why that might be. But more or less, he's shooting at the player. You can see he can destroy the player. And the game doesn't end. Okay, very cool. So, yeah, basically now there's a way for the player to die from these bullets. Now they're still shooting out at a weird angle. So, is that because... oh. Who knows? Let's add them to the spawner first before we go any further. So basically the idea is that this guy's going to spawn in. First, let's make sure we can shoot him. I didn't think to check that. So actually, first of all, let's watch him shoot at us. Oh, wow. Okay, that's interesting. Might leave that in. It's kind of funny. So notice I can actually destroy his bullets. That's kind of what I wanted. Shooting backwards now. Oh, it's because I use forward. Okay. I'm not a big fan of 2D. I like 3D a little better. All right. So we can kill him. We can kill his bullets too, which is really cool. I kind of wanted that. So let's just add him to the spawning pool, and then we will worry about everything else. So we have our enemy. We're going to call it good enough for now. Let's check out our spawner. Our spawner has an enemy prefab that it generates every spawn time. So again, this is the same thing we did for shooting. Every so often, it will spawn an enemy. And then we spawn an enemy here. So what we're going to do is change, instead of just one game object, we're going to make this a list. So list, or an array, sorry. Call it enemy prefabs, plural. And then here, actually I need one more thing. What should we call it? We'll call it public float. I'll call it variant weight. I'll explain why. Variant weight. So what's going to happen is this float will basically be the probability that we spawn a variant. So in this case, we only have one variant. It's the shooter enemy, as opposed to a regular enemy. So for example, if this is 0.2, we would expect to spawn a shooter enemy 20% of the time. The other 0.8, we are spawning a regular enemy. So basically this is going to be a list of all our enemies, starting with the regular enemy and then the shooter enemy. It's going to be ordered like that. And then what we're going to do is in spawn enemy, so whenever we spawn an enemy, we're going to basically have to determine which one we want to spawn. So this is easy, surprisingly. Let's see if I remember how to use random. Random dot next, no, that's different language. Random dot range, seems like it would work. Inclusive. Sure. 0, 1F. So this will generate a random number from 0 to 1. Sounds good. And then we'll just say, hey, if that number is less than variant weight, then we will try to spawn the shooter enemy. Otherwise, spawn a regular enemy. So let's just do that. Let's move this up here. Yep. Actually, no. Sorry, let's move that back down. My bad. So here, we're going to say game object chosen, should be an uppercase G, chosen enemy. And now if we choose the variant, then we're going to say, hey, okay, chosen enemy equals, what did I call it? Enemy prefabs, yes, 1. So this is basic arrays right here. Basically, so first we do a random check, because this number can be anything between 0 and 1 uniformly. So if it's less than 0.2, which will happen 20% of the time, then we're going to say, okay, the chosen enemy is this one, and we'll make sure that we make this one the shooter enemy. Otherwise, the other 80% of the time, we will access this one, which we'll say to be the regular enemy. And then why? Okay, yeah, here. And then here we do chosen enemy. And then we spawn in whichever enemy we chose. And then there's already a... we're already spawning in a random location, so we don't really need to worry about this. That's all done for us. Basically, all we've added to this script is saying, hey, there's other things to choose from, basically, and choose from those at some probability. It's going to tell me to make it ternary. Yeah. All right. Come here. Let's re-enable the spawner. Disable this guy. And let's, oh, and then finally, notice now, this is actually really cool in the Unity inspector. There's now a list here that we can add to. So we know we want the first one to be our enemy prefab, and the second one to be our shooter enemy prefab. And notice this one's at index 0, which is the 80% of the time one, and this one's at index 1, the 20% of the time one. So let's hit play. Oh, wait, hold up. Variant weight 0.2. All right. Now let's try it out. Might need to make this a little faster. Oh no, they're starting in. Oh, it's because I disabled the prefabs. Presumably. Let's find out. Yeah, there we go. So we got a regular enemy. Spawner, please. Spawner has decided to stop working. Very cool. Why is that? Game might have been destroyed, but you're still trying to access it. Huh? Clones enemy equals instantiate chosen enemy. Oh, oops. I think okay, my bad. So what I did here is in the spawner, I dragged in these objects. I think I need to drag in the prefabs instead, like this. Shouldn't really make a difference, but it might. Let's find out. It's the fun part. Okay, so we're spawning a bunch of ghosts. The question is, are we going to spawn in a shooter enemy anytime soon? Should at some point. Maybe we're just getting really unlucky. So it's clear. Oh, there we go. Oh, I shouldn't have killed him so fast. He didn't seem to want to be looking at us, but there we go. Is he going to do anything, or is he dead on arrival? He's looking a little inactive there. All right, well, the spawning's working. Notice, oh, they can push him around. That's actually really funny. I didn't think about that. All right, so the spawning's working. You can see they're getting spawned in. There's still an issue where, for some reason, he doesn't want to look at us. For some reason, SMH. Oh, I know why. Okay. So here, does it? Hold on. What you want? What you need? What you want? So the error here is that the variable of player of shooter enemy has not been defined, so it's not seeing the player for some reason, even though very clearly it should be. How do these guys do it? Ah, here we go. So here what we're doing is we're saying, hey, enemy, like whenever we spawn an enemy, we're saying, hey, get the enemy component and set its player to, like the player transform to the player's transform. We need to do the same thing if it's a shooter enemy. So you can do this just fine. It's not the most efficient, but it gets the job done. Because if there is no enemy component, like our shooter enemy has a shooter enemy component, but not an enemy component, it just won't do anything. So this won't do anything. So that's okay. We can do both every time. Again, it's not the most efficient, but it's also not horrible because this is happening once every like 2 seconds. So who really cares? So let's see if we can get some... Oh, okay, he spawned on us. That's unfortunate. That's just a little issue with the game itself. I don't know if I want to do anything about that. I'm so awful at this game. Come on, I just want to see one of these guys. I could just change the probability up to 100. That's what I might do, honestly. Oh, there he goes. No, no, he doesn't wanna. Don't wanna do anything. Okay, why is that? Player at opposition. It's not seeing player. Is it because I? Wait a minute. Huh? Okay. Cloned enemy player dot component shooter enemy dot player equals. Yeah. Okay. What's going on here? By the way, if you have any questions about like anything I'm doing, because I'm going kind of fast, like debugging and stuff, if you have any questions, just make sure you let me know. Like if you're like not sure why I did something or any of that stuff, just let me know. Debugging is half the fun of making a game. Oh, it shows I never even used only XY. Alright. So the issue is that we're not seeing the player. You can see that from here. Variable player of shooter enemy has not been assigned. Why not? I should be assigning it. So let's actually debug. Let's set our spawner to spawn those guys 100% of the time. Okay, don't spawn them on me, please. Okay, pause. Okay, so we have this guy. Scroll down. Indeed, he does not have the player or the bullet prefab. Huh? Why doesn't he have the bullet? He should definitely have the bullet prefab. So clearly something's... Oh, there we go. So first of all, bullet prefab. Wavy. Bullet. And then... There's no way that was the issue, right? I don't think so. But that's another issue that we have now identified. So again, pause it. Let's see what we got. Shooter enemy. So now he has the wavy bullet. He, however, does not have a player transform. So the question is, why is that? He should have the player's transform here. And if we check our spawner, we're trying to do that. But for some reason, this isn't working. Try removing this and see what happens. Maybe you can't actually do that. Maybe what I thought was inefficient is actually just not possible. I wouldn't know because I only write good code. That's a joke. All right. Oh, there we go. God damn it. Well, they're pretty intimidating while they're there. You know, I must say. All right. So issues with Wavy Bullet and with this thing. It's on the enemy layer. This guy's on the enemy layer. Oh, he doesn't have the enemy tag. See, so what the issue was, the reason why all this stuff is happening is because I was editing these up here, which aren't the real prefabs. These are like instances of it. So even though this one has the enemy tag, this one doesn't. So that's actually maybe a good note. When you try to edit a prefab, right, something you want to spawn over and over again, make sure you're editing this one, not the ones in your scene, because the ones in your scene are not tied to these files down here. They can change. So if I come down here and change this guy to have the enemy tag, he's already in the enemy layer. This guy has the enemy tag. One more shot, please. Oh, I also noticed another problem. There we go. So as you can see, they're all shooting at me. They're all quite angry. Awesome. So one more problem, but that should be a pretty easy fix. So the last problem is that they're spawning facing the wrong direction. That's, again, same thing. This one, notice it's flipped on the X. This one, not flipped on the X. So again, that's the difference between the prefab and this. So I believe I can remove these two. We'll see if that causes a problem. It shouldn't, but who knows. There we go. There's a guy down there. He's going to shoot at us. Kill him. And they're actually shooting at me pretty well. That looks like it's all pretty much at me. And there we go. We've just added basically a new person to the game. As you can see, they can't shoot each other. You can see that the bullets don't affect them. Definitely affect me, though. Notice I disappear instantly. All right. And now, last thing we need to do to restore the game to its like original state. kind of is just change this to 0.2, or we could change it to whatever we want. I'm going to go with 0.2. Basically, about one in every 5 enemies is going to be, God. Yeah, their hitbox is a bit big. I should probably make them a bit smaller. Hitbox is a little big, so they spawn on you quite frequently. This guy doesn't want to move. Oh, oops. Is that because I removed this? So basically, I removed it telling it to give it the player component, so it didn't know where the player was, so it's just sitting there still. Look, he's running at me. They're all running at me. Okay, yeah, so it is an issue. So basically what's happening, I was wrong, you can't do this. This is throwing an error because the enemy, our shooter enemy, does not have an enemy component. It has a shooter enemy component. So that's an easy fix. We can say, basically, hey, if we have an enemy component, then set the enemy component's player field to the player transform. Otherwise, set the shooter enemy. We don't really need to check, like, hey, if they have the shooter enemy component, because we know they will, because our game we only have 2 variants. However, if you wanted to like add more enemies later and stuff, the better practice would be to check each time, or like do it in here or something. Like, for example, instantiate the enemy here and then set the correct component there. This isn't really best practice, like doing the else like this, because then if you had a third type of enemy, the charging enemy or whatever, this code will break again. You'll have to change it again. But it works for us, and this is supposed to be a quick thing, so I'll make a note of that. But yeah, so let's give it one more shot. Should in theory work. Here comes that guy. Look at them. He's looking at us. Oh, it looked like he shot a ghost there for a second. That was kind of funny. And I think the game's working fully. Some stuff there. Ghost coming out of nowhere. Give me another shooting guy. Looks like the rotation actually is correct. Spawned a bunch all at once. All I had to do was, oh look, there's a guy up there we can't see. What we had to do to change the thing to rotating correctly was just making sure that we removed the z-axis, or shooter enemy. We removed the z-axis from the difference so that it only cares about the x and y, and then the z-axis won't move. It'll basically stay always. It will never rotate on the it'll never rotate incorrectly, basically. It'll only rotate on the z-axis. So it'll just point at us as we would expect in 2D without like rotating in a weird way in 3D. So that's what this does here. Before I had it as just difference, now it says only XY, which is ignoring the Z difference. All right, so at this point we have a pretty functional game. I'm gonna try to add in a little bit of environment, maybe like some map stuff. But any questions at this point? About anything we've done so far, about adding anything like that? All right, if not, we're gonna add a few things to the map really fast. We're gonna add some trees, I guess. Yeah, sure, why not? So, thing about trees is that the player can't go through them, but everything else can. I also have some rocks, it'll be good. So, pull out our sprites. I have my amazing rock and tree sprites. So, yeah, look at that, beautiful. So here we have our tree. Hold on, I just need to hop into orthographic. There we go, much better. Whoa, that's weird. There we go. Okay. Why is it still? Okay, please just give me this view. There we go. Oh, it's middle mouse. I'm so used to, what am I used to? Some other program. I don't know. Come here and then middle mouse. There we go. Okay. So zoom out a little bit. Let's make this guy a little bit bigger. I think that's good. All right. So this is our tree right here. And Again, the thing is, player can't go through it, but we're going to say the ghosts can, and bullets also can. So it's going to be like a little interesting physics thing happening here. So we have our tree. It has its sprite renderer. We're also going to give it a collider. It's going to be where all the magic happens. And as in most 2D games, the tops of the trees really shouldn't count. So what I'm going to do is I'm just going to edit this collider. Do that by hitting these like 3 little dots here. And then by very precisely clicking on this little top one, I can change the size of the collider. So I'm going to change it to something like this. This is a very common thing in 2D games. If you think about like Pokemon, for example, at least the old ones, you can walk behind the trees, even though they're 2D, but you can't like walk like through the trunks. So basically what this is doing is like going to give the illusion that, back here is like behind the trees, but this is in the trees. So it'll look okay. Because we don't want the hitbox to be the full thing. It would be weird if you were walking here and couldn't walk through, because clearly there's nothing touching the ground there. That's just like weird 2D perspective. So yeah, we're going to do something like this. And then we're going to test it. Doesn't work. Okay, so let's give this a rigid body. I don't think the player has a rigid body. Oops, rigid body 2D. And then we're going to make it not simulated. No, sorry, make this static. So what static is basically it's a thing that cannot move. So this just won't move. It basically acts as like unmovable objects or immovable objects. So let's give it a shot. Shouldn't be able to move. Do we not have a rigid body on the player? Oh. It's going to be a little awkward. Let's try this out. This might be a little awkward. We're going to see if this works. It's a little unfortunate. Kind of thought the player had set up a rigid body. Apparently not. What can we do about this? This actually might be what we wanted. No, it's not. Okay. We're gonna have to. So we didn't really set up our project with like this kind of collision in mind because player didn't have a rigid body or anything. So let me project settings. Default can interact with player. Okay. So my question, what I'm trying to solve right now, is we have our player tree with, tree collider, and it's static. So it's not moving. And then we have our player, which in theory, make it dynamic, don't use gravity. Let's give this a shot. This actually might work. Might be a bit janky, but it might work. There we go. It is a bit janky, I was correct, but it works. And that's what we care about. So here's what's happening. Now that it's a dynamic body, you can see it can interact with the trees. We can't move through the trees. Bullets can destroy the trees. Maybe that's a feature we could leave in. Also, I'm noticing bullets are killing the ghosts. Oh, one spawned on me. Starting to wonder if that's actually kind of a cool thing. That's the fun thing about game design. There's a lot you can do with that. So real quick, let's solve the bullets killing the trees issue. We can use tags again. So let's give this a new tag called environment. Or actually, no, don't do that. Better idea. New layer called environment. And now the player is on the player layer and everything else is on something else. So what we can do is go to our project settings, and in the same way that we disabled collisions between the player and bullets, so its own bullets, and bullets can't hit themselves, we can say, hey, the environment cannot interact with enemies or bullets. So basically what this is going to do is bullets will pass right through the trees, enemies will pass right through the trees, but the player cannot pass through the trees. The player will interact with the environment. So that's the fun part of the matrix here. Yes, it is called the physics matrix. So we can interact with it. So get it. Oh, ghosts are still interacting with it. Let's figure out why that is. Oh, maybe it's because I didn't save it in time. Let's try this. Let's try it one more time. Go right through it. Doesn't want to go through it. And my bolts are still interacting, so clearly I did not do something correct. Could it be that this isn't even on the layer? It could be. So not that the tree is actually on the environment layer. I can interact. Bullets go right through. Perfect. The spawning is interesting. So let's go up here. I'll let that guy shoot at me. Oh my god, they just spawn on top of me every time. That's unfortunate. Fixing that would be easy enough with, like, go through it. Yeah, look at them. They're all going through the trees now. So now I'm the only one who can't go through the trees. But notice my bullets still can. All the enemies can. This makes it a little harder for me, but not like any... Oh my god, things are going so fast. Again, it's a little harder for me now, but like for the enemies and for my bullets, it's not... For them, it's not any harder. So I don't have to add any extra like AI to like go around things. I don't have to add any... There's very minimal work on my part. Now that I have it set up, there's no weird AI. Ghosts don't need to like pathfind around obstacles. They just need to come towards me still, because they don't have to worry about hitting the trees like this. I don't have to worry about bullets hitting the trees and despawning. They're just going to pass right by. These guys don't have to worry about trying to shoot around the trees or anything. All the work is done for me. All I did is make sure I had a rigid body on the player. Actually, the tree doesn't even need one, I don't think. But the player does. Actually, let's do an experiment. I don't think that this needs... No, it definitely does need a rigid body. Never mind. This probably doesn't, though. Unless 2D works differently from 3D, which is very possible. But essentially what's happening is now we can make as many environment things, pieces, as we want. So let's zoom out a bit. Let's add a few more trees. Just duplicate them and place them everywhere. They are very copy and pasteable. Just to give a little bit more challenge to the player and restrict the movement a little bit. And then I'm going to make another one. But this one, I'm going to give my amazing rock texture. Going to need to change that collider a bit so it actually matches the rock somewhat. Perfect. And now let's put the sky, let's make like a border kind of up there. So that player can't really, I mean, you could put a whole border, that would take a while though, so I'm just going to kind of put a few. Like that. Little ring, battle royale style. All right. Let's hit play and see what happens. It's going to be interesting. So I can't go through the trees. I can't go through the rocks. The camera could probably afford to be a little further back so we could see more. But this is basically an even fuller game than the one that was created last time. Here, I can increase, what is it? The viewport rectangle, 1.2, 1.2? Does that not want to do anything? No. I have 1.3, 2, 12. Sure, it just does not care that I'm changing it. All right, whatever. Are there any questions about where we are at this point in the game? We have multiple enemies spawning. We have different bullet prefabs, different enemy prefabs for that matter. Gun enemy and ghost. We have little environment pieces that can deter the player, but it's clearly not affecting the ghosts or any of the bullets or anything like that. The ghosts collide with each other, but they're not colliding with any environment. Bullets are colliding what looks like correctly. So any questions about where we are? None? If you have any, just feel free to ask in VC text chat. Otherwise, I think I'm going to end it here. We are at is 8:40, so we've been going for a while now. So I think I'm going to end it here. If you have any other questions, feel free to ask. Otherwise, thank you guys for coming. I hope you learned a little bit about, writing code that hopefully is, reusable with prefabs and stuff. That's kind of the goal. So, yeah, if you have any other questions, let me know. Otherwise, see you guys either on Tuesday or Sunday, depending on where you're coming. Remember, if you're coming Tuesday, especially with your group, please sign up ahead of time. You can sign up like your whole group or just individually. So if you're not coming with the group, then sign up individually. Otherwise, like have one person sign up the group. Sunday, anyone can come. Still looking like it's going to be the same place on Cook Dog. So.
Thank you.
No problem.